Okay, solve and give solutions in 0 to 2 pi. So it's only one trig function of theta, and it's 3 theta. So we're going to focus on isolating sine of theta, but it's sine of 3 theta. We won't touch the 3 theta just yet. So let's go ahead and isolate the trig function. 2 sine 3 theta equals -1, and sine of 3 theta is -1/2. So again, my goal is to figure out when sine of something is equal to -1/2. That happens in two places, quadrants 3 and 4. It looks like it's gonna be a special angle. So sine of 3 theta is opposite over hypotenuse. If I'm standing here, opposite over hypotenuse, so this must be √3, and this must be -√3. And we know that this little angle right here is across the 1 or the -1, it's pi over 6 or 30 degrees. So since I'm given these directions to find the solution in 0 to 2 pi, I'm going to go ahead and use positive angles instead of going clockwise. So one of them is this guy right here, the angle I'm looking for, and the other one is going to be this right here. So the one in red looks like I'm going all the way to pi. So if I'm counting by pi over 6's, that's 6 pi over 6, and then one more, that's going to be 7 pi over 6, plus 2k pi if I want to pick up all of them. And then I'll deal with k to figure out some angles between 0 and 2 pi. And the one in blue is going to be not all the way to 2 pi, which would be 12 pi over 6, but one short of 12 pi over 6, so 11 pi over 6. And then if I want to pick up all of them, plus 2k pi. So what I just did was I found when sine is equal to -1/2, which means I took care of the sine part. So in other words, I took sine inverse of both sides, if you want to think of it that way. And so we've untrapped the 3 theta. So 3 theta is either equal to this or this right here. So 3 theta, we're going to isolate theta and divide everybody by 3. So we're going to have theta equals 7 pi over 18 plus 2/3 k pi. And then when we isolate theta and the other one, we have theta equals 11 pi over 18 plus 2/3 k pi. And since I'm supposed to find angles only between 0 and 2 pi, I will just go ahead and let k be different values to pick up some positive angles until I go outside of 2 pi. So I'll start with k equals 0. And when k is equal to 0, this piece is gone, and I get 7 pi over 18. When k is equal to 1, we're going to plug that in, and we're going to get 7 pi over 18 plus 2/3 pi, or 2 pi over 3, get a common denominator. And once I do that, I get 19 pi over 3, or 19 pi over 18. Now if I let k be equals to 3, you'll notice what happens if k is equal to 3. If k is equal to 3, I don't need to really evaluate anything, because if I go here, 7 pi over 18 plus 2/3, if k is 3, I'm already adding 2 pi to this angle. So I'm going to go outside of this 0 to 2 pi range. So this we can toss out. So outside of the 0 to 2 pi range, again, because I'm adding, once the 3's cancel, I'm adding a 2 pi. So when k is 0, I get one answer. When k is equal to 1, I get another answer. And similarly, 0 and 1 will give me 2 more values here with the other piece. So let's go get those. K equals 0 is easy. The 2/3 k pi disappears. K equals 1. So k equals 1, we get, oh, I skipped k equals 2. Here, I jumped to 3. Let's go look at k equals 2, because we actually get a value for k equals 2. So far, I guess k equals 0 for this one. I got 11 pi over 18 and 23 pi over 18. And for 0, 1, I have there 2. And again, I don't know why I skipped k equals 2, because that'll give me a valid answer. So let's let k equals 2 into this piece. So once I put k equals 2 here, that's 2 times 2, 4 pi over 3. So 7 pi over 18 plus 4 pi over 3, and I get 31 pi over 18. for a k value of 2 here, and k value of 2 here, and then we should be done. 3 again would cause this to go outside of the 2 pi range because I'll have 11 pi over 18 plus 2 pi once the 3's cancel. So I have 11 pi over 18 plus 4 pi over 3 once I put the 2 in here. And it looks like once I do the math, I get 35 pi over 18. So ultimately, I ended up with 6 answers between 0 and 2 pi. The angles are 1, 2, 3, 4, 5, 6 of them right here. Let's go look at a couple more. So same directions, let's find all the solutions between 0 and 2 pi. The trig function that we're going to focus on here is secant 4 theta, so we're going to try to isolate that. And that's going to give me secant 4 theta equals 2. And now the angle that's locked in is the 4 theta. We're more used to cosine, so let's change that into reciprocals. Cosine 4 theta equals a half. So I'm interested in unlocking cosine 4 theta, or just the 4 theta part. Cosine is positive in the first quadrant and fourth quadrant. Adjacent over hypotenuse, adjacent over hypotenuse, so this must be the root 3 side. And so I have, I guess, 2 angles. One of them is this one I'm looking at, and I'm going to go in the positive direction because it's at 0 to 2 pi. And the other one we're going to look at is this one right here, and we do know what that little reference angle is. It's across the root 3, so it must be 60 degrees or pi over 3. So the red one is just pi over 3, and then we're going to add 2k pi to it to pick up all the other ones, k being an integer, of course. And the blue one is going to be, if I were to go all the way around, it would be 2 pi, which would be 6 pi over 3. But I'm just going to stop one short, so we'll make it 5 pi over 3 plus 2k pi. And those are basically what 4 theta equals. So we've just unlocked 4 theta. And I can divide them by 4. So divide both sides by 4. And we get theta equals pi over 12 plus, I guess, k pi over 2. And then the other one will be 5 pi over 12 plus k pi over 2 once I reduce. And it looks like in this case I can let k be 0, I can let it be 1, I can let it be 2, I can let it be 3. But once I let k be equal to 4, notice 4 divided by 2 is 2, I'll end up with pi over 12 plus 2 pi, which will be outside the range we're supposed to pick the angles. So I can go up to 3, and same thing here, because once k is 4, we're going to add a 2 pi, and that goes outside of the 2 pi we need. So there's going to be more answers here for all the values, and we'll go ahead and quickly do those. So when k is 0, that part is gone, we just get pi over 12. When k is 1, I have pi over 12 plus pi over 2. Getting a common denominator, we get 7 pi over 12. When k is 2, I'm only adding up pi, so that's 13 pi over 12. And when k is 3, I'm adding a 3 pi over 2. And with a common denominator, it looks like I get 19 pi over 12. So those are 4 answers that popped out from the first piece. The same thing will give us 4 more solutions from the second piece. So k equals 0 gives us 5 pi over 12, k equals 1, 11 pi over 12, k equals 2, 17 pi over 12, and k equals 3, 23 pi over 12. So we end up getting 8 solutions in the interval that was given to us. Okay, let's look at one more. So we have a trig function tangent of something. So I have my eye on tangent of theta over 4, and I'm going to isolate that trig function of theta. So tangent of theta over 4 is going to be equal to negative root 3. So this guy is what I have my eye on, and I want to unlock it. So tangent is negative in the second quadrant and in the 4th quadrant, so I'll make representative little angles. Tangent is opposite over adjacent, and opposite over adjacent. So this must be the hypotenuse of 2. And I'm looking at this angle, which I know has a reference angle of across the root 3, again is pi over 3 or 60 degrees. So it looks like I end up with not going all the way around to 3 pi over 3, but stopping one short of 3 pi over 3, which would give me the pi. So stopping one short of 3 pi over 3 with one short of pi over 3 is 2 pi over 3. So 2 pi over 3 is what I get. And in order to get the other one, it looks like all I got to do is just add pi, and then to get the next one, add pi again. To get the next one, add pi. So this time we're going to add k pi. And I have just found out that theta over 4, once I've taken the tangent of it being negative root 3 into account, theta over 4 is 2 pi over 3 plus k pi. So to isolate theta, it looks like this time I'm going to multiply everybody by 4. So we're going to get theta equals 8 pi over 3 plus, distributing the 4k pi. And we're supposed to find angles between 0 and 2 pi. And it looks like even if I let k be equal to 0, I'm going to get 8 pi over 3, which is already bigger than 6 pi over 3, which is 2 pi. So this is already outside of what I'm looking for. And if I let k be equal to 1, well, that's even a bigger angle. K equal to 2, even a bigger angle. So it looks like this thing has no solution between 0 and 2 pi. Now, what does that really mean? Let's think about it. It means if I look at the left side of the equation and the right side of the equation, so if I look at y1 being tangent of theta over 4 and y2 being just the negative root 3 horizontal line, these two guys never intersect in the interval 0 to 2 pi. So in the interval of 0 to 2 pi, these guys don't intersect. Let's go quickly look at the graph of this. So into y1, I put tan of x over 4 or theta over 4, and into y2, I put negative root 3. And let's go choose the appropriate window. Let's put 0 to 2 pi. For our x's or thetas, and then for the y values, let's just put like, I don't know, negative 10 to 10. We know the function, tangent function, goes off to infinity and negative infinity. Oh, let me make sure that one was just a scale of 1, that's the x scale. So y min, let's say negative 10 to positive 10, and let's look at the graph. So there's the tangent function, just that little piece of it that we see. And there's the line y equals negative root 3. And notice in that window between 0 and 2 pi, they do not intersect. So they have no, that equation has no solution if we were to look at it graphically. If I go and change my window to negative 2 pi to 2 pi, notice that if I go from negative 2 pi to positive 2 pi, there will be one solution, which I can get with the intersect feature. So we were only restricted to positive angles, and there is no solution.